properties, what are the properties of solution? Properties of solution. When we are studying about the solution, children, don't you find that there is some similarity in between the mixture and the solution? Mixture is also called as solution. No new substance is formed, and whatever we are adding, they are not chemically reacting, right? So, properties, when we study about the properties of solution, you will come to understand that there are many similar properties. So, there are many similarities in between a mixture and a solution. So, first property is, it is homogeneous mixture. Can you distinguish the salt particle in salt solution? Can you distinguish sugar in sugar solution? No. So, it is a homogeneous mixture. Then components do not chemically react. Components do not chemically react. In salt solution or sugar solution, do this salt, it reacts with water? No. So, components do not chemically react. It is a homogeneous mixture. Then particles, they are very small. Very small in diameter. So, can you see the particles? They are very small, you cannot see, and the size is about 1 nanometer. Size of the particle, it is about 1 nanometer. So, you can say that the particles are very small, you cannot see. Then path of light is not visible in solution. Path of light is not visible in solution. I am just explaining it to you. Path of light is not visible in solution because particle size is so small particle size is so small that they do not scatter, that they do not scatter beam of light. Now, children, if suppose you have a room and that room is completely dark, and in that dark room there is a hole, and from that hole some light is coming. You might have observed that the particles, dust particles, you can see, or otherwise in the picture hall, the film is projected from the back, and that light which is coming on the screen, you can see in that light dust particles. Why you can see that light? Because those dust particles, they are bigger in size and they can scatter beam of light, and because they can scatter beam of light, so that light is visible to you. Same case in a dark room. When there is a hole in the dark room and the light is coming from there, then that light is visible because these dust particles which are present here, they are bigger in size and they can scatter the beam of light, so that light is visible to you. But here in the solution, the path of light is not visible. If suppose you have a beaker and in this beaker you have water and you have of course this salt particles also, salt particles are also there. These are the salt particles, but their size is very small. How much small it is? The diameter of this particle is 1 nanometer, and because of this small size, when the light falls on this particle, then the beam of light is not scattered and therefore the path of light is not visible. Path of light is not visible, right? Then next property is that when solution is poured, when solution is poured on filter paper, no solid particles are found on paper. It means that if you have filter paper, that then keep that filter paper in a funnel and pour the solution on that funnel. Then you will see that on that filter paper no solid particles are there. Why solid particles are not there? Again the same thing, that because their size is so small, so they will pass through the filter paper. The holes which are present in the filter paper, they are bigger than the size of this, so these particles they will pass and there will be nothing left on the filter paper, and there will be, or you can say that no residue is left. Then solutions are stable. Next property is solutions are stable. Solutions are stable because when we allow them to stand, undisturbed, then solute particles do not settle down. Solution are stable. Why? Because when we allow them to stand undisturbed, then the solute particles, they do not settle down. Here, this you can do at your home, children, because all of you are having water, all of you are having salt. Try this and compare all these properties which you have learnt here. You see, then it will be very easy for you to understand. So, if suppose this is the water, this is the beaker in which I have taken water, and this is salt particles. So what I am saying is that this is salt solution. This is salt solution. What I am saying here is that salt solution, these solutions are stable. Why they are stable? Because when we allow them to stand undisturbed, I leave this solution undisturbed for an hour. Then what happens? Solute particles, they do not settle down at bottom. It will not happen that all the particles of salt will come down. It will not happen. What will happen? It will remain as it is. As it is means it is stable. Right? So, these are all the properties of solution. Then next comes one more property is there, that is solution is transparent. Solution is transparent. It may be colored. Here this is salt solution. Take some salt, dissolve it in water and see that it is transparent. Transparent means through that you can see. It may be colored. If suppose you take copper sulfate as a solute, or you take potassium permanganate KMnO4 as a solute, then this solution, it will be blue in color, and this solution, it will be purple, or you can say violet. Whether it will be purple or violet, that will depend upon the concentration. Means if you have dissolved more of KMnO4, then it will be purple. If you have dissolved less of KMnO4, then it will be violet, right. So, solution is transparent, it may be colored, for example, copper sulfate solution or potassium permanganate solution. Now, concentration of solution. Next topic is concentration of solution. Concentration of solution. Concentration of solution. Here it can be dilute, it can be concentrated, and it can be saturated. What is a dilute solution, what is a concentrated solution, and what is a saturated solution? This also you can do at your home, children. Take some water in a glass, add 1 spoon of sugar in it and stir it, dissolve it. It will get dissolved. This will be called as dilute solution. Half glass water plus 1 spoon sugar. This is dilute solution. Now, you add 1 more spoon of sugar, add 3rd spoon, 4th spoon. Suppose you have added 4 spoon. So, this solution will be, you can say, half glass water plus 4 spoon sugar. What happens here? This will be a concentrated solution. Now, go on adding more of sugar, say 5 spoons, 6 spoons, 7 spoons, 8 spoons. Here, half glass water plus 8 spoon sugar. Half glass water plus 8 spoon of sugar. you will see that when you are dissolving more and more of sugar, then this sugar does not get dissolved. A condition comes that the sugar does not get dissolved. Say with 1/8 spoon of sugar, you are not able to dissolve more of sugar. So, this solution will be called as saturated solution. Saturated solution means a condition has come after which you are not able to dissolve any more of solvent in that solvent. So, this kind of solution, it is called as saturated solution. Now, concentration you can define as definition of concentration. Definition of concentration. What is concentration? Amount of solute dissolved in a given mass or volume of solvent. Definition of concentration is amount of solute dissolved in a given mass or volume of solvent. Here solute is what? Sugar, and solvent is what? Water. So, amount of sugar dissolved in the given mass of water or given volume of water. This will be called as concentration, and we usually represented by percent, right. So, there is a formula for finding out the percentage of dilution, and of concentration of solution by mass. It is equal to mass of solute upon mass of solution into 100. Concentration of solution, it is given by, in terms of mass, it is given by mass of solute upon mass of solution into 100. Now, concentration of solution by volume, in terms of volume, it is mass of solute upon volume of solution into 100. So, concentration you can find out either in the terms of mass or in the terms of volume. Let us solve some of the problems or numericals on this concentration of solution. Problem first in your study material. Problem first in your study material, I am reading it out. A solution contains 40 grams of common salt in 320 grams of water. Calculate the concentration in terms of mass by mass percentage of the solution. Here what you have to calculate? You have to calculate the concentration in terms of concentration of solution in terms of mass. So, what are the things which you require here? That is mass of solute, mass of solution, right. Here what is given? A solution contains 40 grams of common salt. So, mass of solute will be 40 grams of common salt in 320 grams of water. Solvent is equal to 320 grams. Here you, what do you want? Mass of solution. Mass of solution means mass of solvent plus mass of solute, right. So, mass of solution, it is equal to mass of solute plus mass of solvent. What is the mass of solute here? 40 grams. And what is the mass of solvent here? 320 grams. So, mass of solution will be 360 grams. And so, here mass of solution is equal to 360 grams. And what does this formula stands here? Mass of solute is equal to 40 grams and mass of solution is equal to 360 grams into 100. This you can find out. Next problem, second problem in your study material. See children, calculate the mass of glucose and the mass of water required to make 250 grams of 25% solution of glucose. You have to calculate the mass of glucose, what is glucose here? This is solute. And you have to calculate mass of water. What is water here? It is solvent. And what is given here? You have to calculate mass of glucose and mass of water required to make 250 grams of solution. Mass of solution is given. Mass of solution is given. And percentage, dilution percentage is also given, that is 25% of solution of glucose. So, two things are given, you have to find out two more things. And we have the formula that mass of solute upon mass of solution into 100, and this is equal to what? Concentration of solution. Here we are given concentration of solution, that is 25%. Here mass of solute is equal to how much? That is, that you have to find out, right? And next thing is mass of solution. Mass of solution is given, that is equal to 250. Here mass of solution is given, that is 250 into 100. What is this? This is mass of solute. into 100. So, concentration of solution is given, that is 25%. Mass of solution is given, that is 250 grams. You have to find out mass of solute and mass of solvent. So, out of 4, these 3 things are given. Mass of solute you can calculate, you can find it out, and mass of this solution is given. Subtract that mass of solute from this mass of solution, you will get the mass of solvent or mass of water. Clear? So, that is the second problem which is given in your study material. Then next is a problem or numerical based on volume. Either you can calculate a solution contains 5 ml of alcohol in 70 ml of water. Calculate the volume by volume percentage of the solution. Now, volume by volume percentage of solution. This formula we already know that this is equal to volume of solute upon volume of solution into 100. Now, what is given here? A solution contains 5 ml of alcohol. So, it is what kind of solution? Liquid in liquid solution. Alcohol is also liquid and water is also liquid. So, but which quantity is less here? Alcohol. So, I told you that quantity which is less, that will be called a solute. So, solute will be, volume of solute will be that is alcohol. It is equal to 5 ml, and a solution contains 5 ml of alcohol in 70 ml of water. Volume of solvent, it is equal to 70 ml. What is solvent here? Water. I told you that quantity which is more, that will be solvent. So, water is more, that will be solvent, alcohol is less, it is solute, and this is a liquid solution, liquid dissolved in liquid. So, volume of solute will be 5 ml, this volume, and volume of solution will be how much? Volume of solution will be 70 plus 5, that is equal to 75. Why we have taken 70 plus 5? Volume of solution is equal to volume of solvent plus volume of solute. So, that will be 75, or you can write 5 upon 75 into 100. That will give you the volume percentage of solution. This will be volume percentage of solution, right. So, this is about the physical and chemical changes, some numerical concentration, solutions, different kinds of solution. True solution we have studied. True solution means the solute particles are so small that they are not visible, and their size is the diameter, size of the diameter it is 1 nanometer. You cannot see you cannot distinguish the solute particles. What is a solvent, what is a solute, what is a solution? This all we have done, right. Now, one more thing, that is suspension. What is the meaning of the word, children? Suspend. Suspend means hanging. If you hang something, if suppose you hang a piece of stone If tie a piece of stone with a thread and hang it in a glass of water, then what will be the position of that stone? It will be suspended. It is suspended in water. Now, try to understand this, children. What is suspension? Chalk powder, or a very common experience at your home, children, that take some flour out of which chapatis are made. That dry flour you take and dissolve it in water, put it in water. Does it get dissolved? No, some parts they go down, but most of the particles you can see in water. They are suspended. They are neither down, nor they are up, nor they are dissolved. You can say that suspended in water. So, this is called as suspension. Another example I am giving you of soil. If you take some soil and put it in water, you will see that the solid particles, that is sand particles, they will settle down at the bottom. But some particles you will see hanging or suspended in that. So, that is called as suspension. Chalk powder you can take. This is a piece of chalk. If I powder it, and if that powder I put in water, then you will see that some of the particles they will settle down at the bottom, but many particles they will remain suspended in water. So, that type of solution is called as suspension. In suspension, solids are dispersed in liquids. Solids are dispersed in liquids. Example, chalk powder in water. Flour in water. Or soil in water. If suppose this is the water and this you have added wheat flour, then what happens here, children, that this wheat flour which you have added here, you will be able to see that this wheat flour particles, they are hanging here. They are hanging, or you can say they are suspended, right. So, they do not go down, they do not dissolve, but here you can see that they are in the suspension way, or you can say they are hanging, right. So, what you have written, that in suspension solid are dispersed in liquid. This is liquid water and this is solid wheat flour. They are dispersed. They are dispersed means they are scattered throughout. They are scattered throughout. So, they are dispersed in liquid. So, this is the example, and these are the particles which are dispersed in liquid. Then, particles are visible through the naked eye. You can easily see them. Visible particles are visible. Another example is paint. Paints which we use for painting the walls. When you bring that paint in a container, keep it for some time, then you will see that many particles are suspending in a liquid. Then first, before painting, what does that person do? He first stirs it and make the solutions, you can say uniform solution, and then he starts painting. So, why? Because it is a suspension solution, and in that suspension solution suspended particles are there, and if he does not stir, then what will happen? The paint which he will do, that will not be even, but it will be uneven paint, right. Now, let us define a suspension. Suspension is a homogeneous, again I have told you what is homogeneous. It is a homogeneous mixture in which solute particles do not dissolve, as I told you, solute particles do not dissolve, as I have shown you also that solute particles do not dissolve, but remain suspended, throughout the bulk. Here, this is suspension. What we are saying, that it is a homogeneous mixture. Homogeneous mixture means, of course, if you leave it undisturbed for some time, then some particles, they will the thick portion, it will settle down, but again after mixing it, stirring it, it will become a homogeneous mixture. It is a homogeneous mixture in which solute particles do not dissolve. These solute particles, they have not dissolved in liquid, but they remain suspended. How they are present here? They are hanging or they are suspended. Where they are suspended? Throughout the bulk. It is not that these are suspended here only or here only or here only. Throughout the bulk they are suspended. So, this is the definition of suspension. Then, properties of suspension. Properties of suspension. First property is, it is